So here's you guys' homework on intro to logarithms. So first, let's talk about a few things. So in your guys' notes, you guys have this. So I'm just gonna say this is log too thick. Okay, so we have log form, which is log b of a is equal to x. And we have something called exponential form, which is b to the x is equal to a. So you can get from log form to exponential form, but if you have exponential form, you can also bring that to log form. Now, notice that the base of the log form is the base of the exponential form, right? And then notice how when you go from here to here, the base is raised to this as a power, and it's equal to the argument, which is a. And that's how you guys get exponential form. So in question 1, it says write, or 1 through 3, it says write each equation in exponential form. So since this has a base of 2, it's going to be 2. This is going to be the power, right? To the 7th is equal to the argument, which is 128. And there's exponential form. Next, we have this base of 8, and we're going to raise it to this as a power. So 8 to the 2nd is equal to 64. Remember, all of this is going from log form to exponential form. All right, 3. So here's the base. So 3 to this as a power, -3 is equal to the argument, which is this, 1 over 27. All right, so all of those were going from log form to exponential form. All right, numbers 4 through 6. Numbers 4 through 6, you guys, is going from exponential form to log form. All right, so log form has logs, right? So log. Now, when we're going from exponential to log form, notice that this is the base, right? And we have to put the argument right next to it. So we're going to get log of 4, because that's the base of 4, and the argument is 256. And that's equal to the power, which is 4. And there's log form. Okay, so here's the base, which is this, and this is the base for the log form. So log base 8, and now we're going to put the argument, 512, is equal to the power, which is 3. Number 6, you have log of the base, which is that, so 27 to the argument, which is 9, and that's going to equal the power, which is 2/3. So that's just some good practice from log form to exponential and exponential to log form. All right, so now we have something called this. So we're going to simplify this using our knowledge of log form and exponential form. So I'm going to bring this down so we have a reference. Yeah, I'll just write it right there. Okay, so we have that as a reference. So I am just going to set this equal to x, and then I'm going to change all the log forms to exponential form. So 6 to the power of x is equal to 36. Now, notice that we went from log form to exponential, right? So this is base, and raise it to this power, which is 6 to the x, is equal to the argument, which is 36. And now let's solve. Well, let's get both sides to have a common base. So 6 to the x is equal to 6 to the 2x. Oh, sorry, 6 to the second. And now, since they have the same base, now we can equate their exponents. So x is equal to 2. Okay, number 8. So set it equal to x, and let's change it from log form to exponential form. So here's the base, 2. This is always going to be your guys' power. To the x is equal to the argument, which is 32. We're going from here, log form, and we're going to change it to exponential form. Okay, now let's get the same base on both sides. 2 to the x is equal to 2 to the 5th. Same base on both sides, so that means you just equate your guys' exponents, so x is going to equal to 5. Alright, this one, set it equal to x, and now for this, to make it from, this is log form, we're going to exponential. So 4 to the x power is equal to 64. Now let's get them to be the both same base. So 4 to the x is equal to 4 to the 3rd. They have the same base, so that's going to be x is going to equal to 3. Number 10, set it equal to x. And now let's change it from log form to exponential form. Again, I'm just using this formula, you guys. I'm using this conversion for every single problem. So 3 to the x power is equal to 81. Get them to be the same base, so 3 to the 4th. Same bases, so x is going to equal to 4. Alright, for this one, set it equal to x. So base to this has a power, so 100 to the x is equal to 10. Well, we could change the base of 100 to be a base of 10. So base 10 squared x equals 10. This is to the first power, right? So that's going to be 2x is equal to 1. Divide both by 2, x is going to equal to 1/2. This one, so equal to x, so 7 to the x power is equal to 1 over 7. 7 to the x power is equal to, well, 1 over 7, you guys, is 7 to the negative 1. X is equal to negative 1. Alright, 13, set it equal to x. 18 to the x power is equal to 1. Now remember, 1 could be any base, right? To the 0 power, so 18 to the x is equal to 18 to the 0 power. Both have the same base, so x is going to equal to 0. 14. the base to this as a power, so we're going to get 16 to the x is equal to 1/2. They both can be a base of 2. So 2 to the 4x is equal to 2 to the negative 1. Both have the same base, so 4x is going to equal to negative 1. Divide both by 4. X is equal to negative 1/4. Alright, so for 15, you guys, now in our notes, I told you guys, if it doesn't show a base there, let's just set that equal to x, it's automatically 10. So if it doesn't have a base there, it just is a base of 10. So that's going to be 10 to the x power is equal to 1,000. 10 to the x is equal to 10 to the third. 1,000, you guys, is 10 to the third. They have the same bases, so x is going to equal to 3. 16. Set it equal to x, and let's get into exponential form. So 16 to the x power is equal to 8. They both can be a base of 2, so 2 to the 4th times x is 2 to the 4x is equal to 2 to the 3rd. They have the same base, so 4x is equal to 3. Divide both by 4, x is equal to 3/4. 17. So set it equal to x. 243 to the x power is equal to 27. They both could be a power of 3. So 3 to the 5x is equal to 3 to the 3rd. They have the same base, so 5x is equal to 3. Divide both by 5. X is equal to 3/5. Alright, so when you guys do this one, well, first I'll show you. Set equal x, 3 to the x is equal to 92. Now, do you guys notice how 92, there is no 3 to any power that will give you 92, which means that you guys cannot use changing the log form to be exponential form. What you have to do is the change of base formula. So the change of base formula, you guys, is log b of a, okay? That's going to be equal to, this is the change of base formula, log of the argument over the log of the base. And then you guys put this into your guys' calculator. So this one, since this is the argument, right, this is your guys' a value. So log of 92 all over log of 3. And this is what you guys are going to put into your calculator. Log of 92 divided by log of 3. And that's going to be, estimate to be around 4.12. Let's round to your nearest hundredths. So if you guys notice that you can't get the base or the argument to be the same base in exponential form, then you guys have to do the change of base formula, which is that. Okay, 19. Okay, this is another example. I cannot get this to be a power of 7. 7 to some power will not give us that. So we have to do change of base formula. So log of 35 over log of 7. And that's roughly going to be around 1.83. number 20. 260 is not a base of 2, you guys. So we gotta do change of base. So log of 260 over log of 2 is gonna be roughly around 8.02. And lastly, 21. So this one, we have to do change of base formula. So log of 38 divided by log of 5. That's going to be roughly around 2.26. And there you guys have it, okay? So just keep on practicing, and hopefully you guys has helped.